1. Hook cold starts can cost you time and money. But why should you care? Let's dive into why cold starts matter more than you think, and how to tackle them effectively. A cold start can add several seconds to the execution time. That might not sound like much, but think about your users. If your app takes too long to respond, they might leave. This can lead to lost revenue and damage your brand. 3. The simple explanation: when a serverless function is called after a period of inactivity, the cloud provider must spin up a new instance. This process can take anywhere from 200 milliseconds to several seconds, depending on various factors like the platform, the runtime, and the function's size. In simpler terms, imagine you're waiting for a coffee at a cafe. If the barista is busy, your coffee takes longer. That wait time can frustrate you, just like a slow-loading app frustrates users. 4. Real-world example: let's take a look at a startup called Quick Snack. They built a food delivery app that relies on serverless functions. Initially, they didn't think much about cold starts. They saw a spike in traffic when they launched a marketing campaign. However, they soon realized that their functions were taking over 5 seconds to respond during peak hours. This delay led to a 30% drop in user engagement and a 15% decrease in orders during that campaign. After analyzing their performance, they learned that the cold start issue was the main culprit. To fix it, they implemented strategies that reduced the impact of cold starts. As a result, they cut response time down to 1 second and boosted user engagement back to 95%. This translated into a significant revenue increase. 5. What to do instead to minimize cold starts: follow this step-by-step framework. 1. Choose the right runtime. Some runtimes have faster cold start times. For example, Node.js typically has quicker cold starts compared to Java or .NET. Test different runtimes with your specific functions. 2. Optimize your function size. Keep your deployment package small. Aim for under 10 megabytes if possible. Remove unnecessary dependencies to speed up the loading process. 3. Use provision concurrency. If you're on AWS Lambda, consider using provision concurrency. This keeps a certain number of instances warm. Set it based on your traffic patterns. For instance, if you expect peak usage on weekends, provision instances ahead of time. 4. Monitor performance. Use tools like AWS CloudWatch or Google Stackdriver to monitor cold start performance. Set alerts for when your cold starts exceed 1 second. 5. Implement caching strategies. Use caching to store frequently accessed data. This reduces the workload on your functions. Consider using services like Redis or Memcached for fast data retrieval. 6. Common mistakes. Let's look at 5 common mistakes and how to avoid them. 1. Ignoring cold start impact. Thinking cold starts don't matter for small apps. Monitor performance early on. Even small delays can accumulate. 2. Using heavy frameworks. Choosing bulky frameworks that slow down cold starts. Opt for lightweight alternatives. For example, use Express.js over larger frameworks when possible. 3. Neglecting testing. Not testing cold starts in production scenarios. Simulate traffic patterns in a test environment. Use tools like Artillery for load testing. 4. Not leveraging warm-up techniques. Failing to implement warm-up strategies. Schedule periodic invocations of your functions to keep them warm. 5. Overlooking vendor options. Sticking to one cloud provider without exploring alternatives. Compare cloud providers. Some may offer better cold start performance for your use case. 7. Quick checklist. Here's a quick checklist to keep your cold starts in check. Choose an appropriate runtime. Keep your function package size small. Consider using provision concurrency. Monitor performance metrics regularly. Implement effective caching strategies. 8. Summary plus CTA. Cold starts are a significant concern in serverless applications. They can impact user experience and revenue. By understanding the problem, implementing a clear framework, and avoiding common mistakes, you can drastically reduce their impact. If you found this video helpful, drop a comment below with your thoughts or questions. Don't forget to subscribe for more practical tech insights. Let's keep building smarter. Bonus practical tip: if you're unsure what to pick, Start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost. Only upgrade when metrics force the decision, not fear. Quick recap: keep it simple, avoid over-engineering, and build the smallest thing that works. If you want a real demo or checklist, comment demo. Subscribe for practical AWS, DevOps, Docker, and Kubernetes lessons.